if you're working in distributed system, you must have this. Otherwise, you're going to waste tons of time on trying to figure out things that are today becoming trivial because of the amazing work the community has done about it.
This is DevOps Paradox, episode number 199. Test your distributed applications using Helios. Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darren and Victor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darren reading this text and feeling embarrassed that Victor made me do it. Here are your hosts, Darren Pope and Victor Farsick. In the days of old, we would deploy our applications. Somebody that was operating it would yell at us saying, "Hey, you're breaking everything. You're breaking everything." At which point, as a developer, we would say, "Well, give us the logs." We would get the logs. And then we would find out that we don't actually have the log information that we need. Victor, does that story sound very familiar to you?
That's the best case scenario. More probable scenario is that we would yell back at him and then the one who yells more would win.
You'd be doing well if you even had logs to begin with. Because
exactly.
As a developer, you had not really done good logging.
No, there are those extremes that who would do logging every single line of the code with the debug as a prefix.
And then you set your logging up as trace. So then you got everything and
then you find out
else's.
That the real problem is actually that you are crushing your hard disk with logs.
Especially when those were 5400 RPM drives, not SSD. Can you tell that we're older? Well, in today's episode, we have Ran Nozik on today from Helios. Ran, how you doing?
Doing great.
So today we're going to be talking about OpenTelemetry. And in theory, OpenTelemetry is now the magic that makes everything work. That whole scenario that I just spelled out, in theory, disappears in the face of OpenTelemetry. Or is that true, Ran?
Well, it certainly makes it easier. I've been doing software engineering for more than a decade, and I think I saw it develops as it goes. I mean, when I started writing software, like at the beginning of the 2010s, I was working on a desktop application, Windows desktop application, actually. And as you said, like whenever there was a problem, we had to add logs, and that meant sending a binary to our customers. And we went through the stage of building a monolith later. So I was working at a mobile security startup. We were building a giant Ruby on Rails monolith. Again, we had this problem of constantly having to add logs, and it was not yet even a distributed system. We were acquired a few years later, and then we had to adapt our architecture. And then problem that led me to be a huge fan of OpenTelemetry started, at least for me.
So what took you down that point? I mean, obviously OpenTelemetry has only been around for, at the time we were recording this, maybe 2 years, right? And really for real for about a year. I mean, to me, OpenTelemetry really started coming to the forefront in late 2021. Do you sort of agree with that?
Yeah, so OpenTelemetry officially started as like a merging of two previous projects, OpenCensus and OpenTracing, in around mid-2019. But it really became mature enough, I would say, about a year ago, as you said. But as I said, there were previous projects that tried to tackle the same issue, same problem of having a distributed system, many components talking to each other, and developers were having lots of trouble understanding what was going on, and had, first of all, they did what developers usually do, is build their own tools. So that's what I did. I built them internally, me and other members of the teams I was working on. And later on, we found out about projects like OpenTracing and Zipkin and Yager. And we knew about non-open source projects like Datadog tracing and numeric tracing, and all of those came together as a joint effort of the community and became OpenTelemetry. As you said, it's true that OpenTelemetry became mature enough, at least in some of its capabilities, about a year ago, but it's something that's been going on, I think, for about maybe 15 or even more years. It started, I think, at Google when they were starting to tackle this problem when they built their scalable system, much before anyone else at those kinds of problems.
To me, what is fascinating about OpenTelemetry is that I rarely see some team coming up with a standard, because I still see telemetry as a standard rather than anything else, that gets adopted by almost everybody in no time. Almost every vendor I know that is doing something with metrics or logs or traces jumped on it, right? That almost never happens.
Yeah, because I think it's almost trivial that everyone works in a distributed architecture needs this kind of solution. So I think Ben Siegelman, who's the founder of Lightstep, said that distributed tracing is nothing else rather than being able to join on logs from different services. And I think that's a great definition. So if you had one service, you had logs. If you have multiple services, you need to be able to join the different transactions based on a common identifier. So I think it's like, if you're working in a distributed system, you must have this. Otherwise, you're going to waste tons of time on trying to figure out things that are today becoming trivial because of the amazing work the community has done about it.
So what do you see as being the real, let's call it the gift? What do you see the gift of OpenTelemetry really is to what we're doing today? Again, you're talking about it being distributed. I'm curious, is there a place for OpenTelemetry as well in a non-distributed environment?
That's a great question. So let me answer it in two parts. First of all, I think there are two kinds of gifts that it gives. The first gift is to the community as a whole. The fact that it became a standard, the fact that there aren't dozens of different vendors doing essentially the same kind of work, like developing the same kind of capabilities, everyone for his own product, for his own use cases. That's something that saves the community a lot of time. Also, the ability to create a standard so the single attribute is called the same way in different systems. That's something the community gets, the community of developers. But that's just on the, I would say, on the philosophical side. On the, I would say, day-to-day side, it's like when I install OpenTelemetry with some of our customers, then it really looks like magic. Sometimes you're actually seeing people getting a first understanding of how their system behaves. The core system is many times like an organism. Maybe an architecture had made some design decisions very early on, but in time, this organism changes and has its own life, and it changes and evolves, and no one really understands how it looks. And when you see people seeing their system for the first time, that's, first of all, amazing to see their reaction. And second of all, it's amazing from my perspective to see how different systems are architected. That's really exciting for me personally. The best part of my job, seeing people getting a first glimpse into what their system actually looks like.
So you're talking about how the system behaves. When we're building our applications, we're not always aware of everything, number one, that is going to be accessing us. And number two, there's no way that we can roll the dice to know what's going to happen 6 months from now. So being able to set up this tracing in such a way, or having this telemetry to us, and I think that's the key point to this name is telemetry, not just tracing, not just logs, but it's telemetry. So all these things make up that, and also metrics, if you want to throw that one there. But I want to go back to the other question of how does this work in a non-distributed environment? Every system is distributed. The question is, do we treat it as distributed, or do we treat it as a monolith? This goes back to old mainframe days. We would treat that as a single system, but in reality, it wasn't a single system.
Yeah, so I think that sometimes even a monolith can benefit from tracing capabilities. And I have a few examples. First of all, in today's world, everyone is using third-party APIs. I come from the security domain, so analysis of Android applications or Salesforce API or Stripe for financial transactions. So everyone is using third-party APIs for tons of different use cases. These API calls are something that is captured by distributed tracing. And so there are many cases in which you can benefit from that as well, not to mention database calls that are also part of the tracing capabilities. So you can get value from distributed tracing even if you're using a monolith. Additionally, sometimes within a monolith, there is something that could be called distributed in its nature. And that is what I call job frameworks like Celery in Python or Rescue in Ruby. And these are jobs that are executed asynchronously by the monolith. They're physically the same service, but in like logically, you could treat any job execution as a different microservice, if you want to call it that. So in these cases, you could also get tons of value from distributed tracing solution by tracing the execution of jobs. So that's another use case in which a monolith can get lots of value from OpenTelemetry or any other tracing solution for that matter.
From the tracing perspective, I might be completely wrong, so correct me, right? Microservices or distributed systems and monoliths are actually essentially the same, right? Because if you have 7 microservices, your request goes to one, and then it is forwarded to another, and then it is forwarded further to more, and then it comes back, and so on and so forth, right? If you have a huge monolith, same thing is happening, just on a different level, a level of functions. And you probably want to put spans in those. Okay, so it is going to the function 1, it takes 2 seconds to process, and then it goes to the function 2, and then from there to 3. The request is still traveling, maybe not as HTTP request, because we are actually communicating not through HTTP within monolith, but still the process, the execution of that something is still traveling somehow, and you want to know where it is going and what it is doing. If we ignore that, we're not talking necessarily about the whole trip being in HTTP anymore in a monolith. The goals and the information I want to find is still the same, in a way.
Yeah, I definitely agree. You got it exactly correct. So distributed tracing takes care of all the inter-service communication, but from my experience, this is never enough. Like even if you're fully in a microservices architecture, still there would always be things that you would like to trace, functions that you'd like to measure, flows of, certain algorithms within your code that you would like to get visibility into. So automatic tracing or automatic instrumentation, as it's called, will never cover all the cases, which is why it's crucial for tracing solution to always support both automatic instrumentation, making sure the basic communication between services, doesn't matter if it's HTTP or gRPC or asynchronous frameworks like Kafka or RabbitMQ, they are traced automatically, but always leave you the ability to add manual spans, as they're called, to track specific behavior that is something that only you as the developer who built your own system will know where to put.
So in OpenTelemetry, we have 3 components, right? Logs, metrics, and traces. Are they all created equal in terms of maturity and usefulness to people?
In the future, there will be. Currently, the tracing is the most mature signal within OpenTelemetry. The next one was also mature, but only about 6 months ago, G8 was the metrics, and logs is something that is becoming more and more mature these days. In some of the languages, it's already GA. In some, it will take a few more months. But actually, there are other signals that are being added to OpenTelemetry these days. The main one that is the community is currently working on is profiling, which is something many APM solutions have already, which is obviously the ability to track the performance of internal function calls within single process, which is something distributed tracing obviously does not handle out of the box.
You were mentioning there the APMs. Those are the Datadogs, the New Relics of the world.
Mm-hmm.
And they're all starting to implement OpenTelemetry, or it appears that they are. Why would I bother, as somebody writing something, why would I bother to run my own OpenTelemetry stack?
There are a few reasons for that. First of all, that's something that's crucial to many customers, the ability not to be vendor locked. OpenTelemetry is a standard and it can be consumed by many backends. One of these backends is Datadog, one of those is New Relic, and there are open source projects as well. Essentially, if you're using OpenTelemetry, you can replace Datadog very easily. If you're using Datadog's tracing solution, then it's going to be a project that might take you a long time, potentially 6 months in some cases that I heard. So that's a good reason to adopt OpenTelemetry. And another reason to do so is because the community is ahead of the vendor-specific solution. So some of the instrumentations that are supported by OpenTelemetry are not supported by, for example, Datadog. So Datadog has, if you're using their Python agent or JavaScript agent, you will not get Kafka tracing, which you will get if you use OpenTelemetry. So there are benefits of doing that, and the amount of people working on maintaining the SDKs in different languages in OpenTelemetry is larger than the number of people doing that in Datadog and New Relic. So that's a good reason, I think, to adopt OpenTelemetry.
It must be tough also for those vendors, right? Because I wouldn't be surprised that quite a few of them thought, at least earlier, maybe not today, kind of that whether that's removing their competitive advantage, right? Because they spent years building SDKs and formats and APIs and what's not. And now the community is telling them, first of all, you're going to redo that, your APIs at least, and maybe your storage and what's not. And then you had competitive advantage compared to somebody else because of what you did. Now you don't. Which is a great thing for us users, right? But it must be a tough decision for the vendors.
I agree. I think it is something that is, I don't think I have all the knowledge of the decision makers in Datadog, because they're obviously one of the biggest contributors to the project. But I think there are some challenges in that for them. I think the main reason they did decide to do that, to adopt OpenTelemetry, at least partially, is because it's not something that can be really an IP of the company that they can defend, because it's client-side code. So if you're giving someone a JavaScript SDK, then everyone can see the code and everyone can use it. And what they, I think, realized is that everyone is also doing the same things anyway. So that's why I think after a few years of trying to make their SDK better than New Relic, for example, they realize that this is going to be an ongoing fight, and that's not going to be they cannot have an advantage. Their competitors cannot close in a relatively short amount of time. So I think that's a reason for them to do so. But I think there's still a challenge for them there, because, for example, all those vendors' SDKs today contain much more functionality than OpenTelemetry. Because if you're buying, for example, New Relic's SDK or Datadog's APM solution, there are many features that are still not part of OpenTelemetry. For example, logging, for example, profiling, as I said, which is going to take, I believe, at least a year to reach GA in OpenTelemetry. So Datadog's also agent has also some security features which are currently not part of OpenTelemetry's premise. So there is a conflict, I think, within Datadog of what's going to happen with OpenTelemetry, because on one hand, if they want to provide their full portfolio of products, they have to sell their own agent, their own SDK. but they still want to help the community. So that's something that me personally, I think I don't have the full perspective on what's their strategy there, but certainly something interesting to watch from outside.
You were talking about language support through different, either Python or Java.
Mm-hmm.
Which languages have the best support across the board today?
So the best languages are currently Java, Node.js, and Python. I think mostly because of the companies that have made the early donations to OpenTelemetry, and obviously because these languages are the most popular ones. Some other languages are gaining more and more features as we, like last week, for example, .NET released for the first time auto-instrumentation, which is something super crucial. Without that, it requires manual code changes from the developers, and that's big friction. Same goes for Go. So Go does not have it yet. We are at Helios actually working on something on that domain, which might be interesting. To summarize, Node, Python, and Java are the most mature SDKs in OpenTelemetry today.
What you're describing is one of the reasons why I was personally postponing adoption of OpenTelemetry, because most of the things I work on or people around me work on is in Go. And in the past, I was thinking, okay, so I can invest time to instrument my applications right now, or I can wait until somebody finally gives us auto-instrumentation. And at one moment, I had to give up, thinking, okay, it's not coming. It's not coming.
So Go is super interesting. I'm relatively new to Go, and it's very different from the other languages we've discussed, because Node and Python are dynamic languages. You can replace function implementations at runtime. It's super easy. Java has a built-in mechanism called the Java agent for doing just that, and Go does not. Go compiles it to native code, and which makes it much harder, or in a sense impossible, at least in runtime. We are actually, as I said, working on something there, so it's super exciting, and I hope we'll share that soon in the next few weeks.
So here's an off-the-wall question. Who does not need to use OpenTelemetry?
So there are some companies who are, I would say, mobile first or mobile only. So I know an Israeli company, a very successful one, who has a very successful mobile product. And their backend is not really important. It's mostly for analytics or user management. So these are obviously important parts of their application, but the main issues do not come from there. So that's one example. I think some companies work in a monolith still today. And obviously, it's fine. It might take them a while longer to do that. Even though what I said before about distributed tracing bringing value to monoliths and using third parties or using asynchronous jobs frameworks, but still they don't feel the pain enough to implement such a product. Even though, from my perspective, I encourage everyone to use it because it's becoming easier and easier, and it will become even more easier in the future.
Does it make sense, or does it bring any additional value to use OpenTelemetry for one way or another for people who are not instrumenting their code? Very often you would have some sort of agent that would be sending metrics about your CPU memory usage, disk drives, things outside of the code of your application. Does it make any difference there?
So OpenTelemetry is designed to support all kinds of signals. So some of the signals are not necessarily coming from an application. For example, two examples that I examined just in the last few days. So I saw an article about getting telemetry data from Kubernetes clusters. So whenever there's an operation happening in the cluster, it's not something in the user application, but rather in the infrastructure itself, you would still get a tree of these operations, which is something that can be very useful for DevOps SREs. So this is not obviously instrumenting an application. Another use case that I saw was instrumenting Jenkins jobs. So again, it's not part of the application, but still you get to track the jobs that are running, how long it took them, maybe a series of jobs, what broke. So It's a format that is really designed to support multiple use cases and get data from various sources. So for example, in the future, as I said, it will also include profiling data, which is very different, obviously, from HTTP requests or database queries, and also networking data that is recorded in the Kubernetes cluster. It's a multi-purpose protocol, has many use cases, and can be used for different purposes rather than instrumenting your own code.
So we mentioned at the top that you're the CTO at Helios. Why don't you talk to us a little bit about Helios and what it's trying to solve in this space?
I come from engineering background, mostly cybersecurity. What me and my co-founder, Eli, felt is that we worked in different places, in distributed applications, and we felt that tracing solutions, we use them. We use them in both the places we're working before starting Helios. And we felt that the distributed tracing solutions that were provided for us were first not adapted for the needs of developers, and second of all, not really user-friendly. What we believe is that so far, distributed tracing was aimed for DevOps and SRE for tackling production issues. And we believe that OpenTelemetry specifically can be leveraged much earlier than that in the dev lifecycle. So for example, what we do is enrich the data collected by OpenTelemetry. We wrap the vanilla OpenTelemetry SDK and collect more data to enable developers to do things like replay scenarios, test scenarios, do trace-based testing, if you heard of that term, get an API catalog. So all kinds of things that that are not relevant for you when you are trying to solve production issues, but are really a game changer for everyone working in a distributed environment. And these environments are today running on your laptop or in your private cloud environment that every developer has, or any other ephemeral environment. So the distributed environments are everywhere, and it doesn't make sense to me to have all those capabilities only when you have problems in production. So that's like the main thing that we're trying to do. Lots of aspects to it that I can talk about.
Well, the one thing that stands out to me is the ability to replay scenarios. For me, that's run this, everything runs fine, but every once in a while I have something blow up. I want to be able to capture that and see, oh, wait, 99% of the time, this value is always within this range, but in this 1%, when things blow up, somebody's gone out of these ranges. And now that would give me the ability, in that case of a replay, now it means, okay, because a normal range is fine, I would write 2 more tests on the outer ranges or the outer edges of that range. To me, that's the most powerful thing that I heard you talk about there. Because then that also leads me into being able to do fuzzing on top of that, which gets into a whole different scenario.
Yeah, so I think what you said is kind of one of the things that led me to this idea. So as I said, I was working for a mobile security company, and we had apps for iOS and Android. And Android, there are tons of vendors out there. And sometimes we saw issues coming from a specific vendor, I don't know, something that is not very common, but was still important enough for us to fix. And we had to try to reproduce these issues that happened on these devices. And what we did, because we could not buy every mobile device in the world, we had to see what HTTP requests they were sending to us. And that took a lot of time because we had to look at the logs and we had to extract all the parameters, and they were sending complex configurations. That is something that with a tool like what we're building right now would have been much, much easier, because whenever we saw a request from this relatively rare type of Android device that is, I don't know, perhaps common in the Indian market, then we would be able to reproduce the scenario easily. So it's not like a range of numbers that you're out of the range, but it's like a specific JSON that we did not expect to receive in our backend. So I really relate to what you said. It's really one of the reasons we build these capabilities, but it's not actually only about HTTP. In today's world, the APIs are not only HTTP. So you have the APIs are asynchronous, like Kafka or RabbitMQ, or even Lambda functions. So sometimes reproducing an issue that happened in Lambda might take you a long time because you have to trigger the Lambda somehow. And this is something that we are also helping our customers with. So that's just another aspect of how important that is from my perspective.
So if people wanted to find out more about Helios, they can go to gethelios.dev. That's gethelios.dev. And Ron, if people wanted to get in touch with you, what would be the best way to do that?
So feel free to contact me via LinkedIn. That would be great.
And that's Ran Nozik. And again, all the links for Helios and for Ron are going to be down in the show notes. Ron, thanks for being with us today.
Thank you very much. Thanks for having me.
We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at devopsparadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.